Okay, today my recording died because there was no file size, or this file size was 0 because there was no room to save it. So anyway, this is going to be a super short lesson on polar. So to change from 2 comma pi over 3, here's what it looks like. A picture's worth 1,000 words. Everybody, please draw me where 2 comma pi over 3 is. That device needs to go on my desk right now. Put it on my desk, please. And this is at 2 comma pi over 3. Here's where pi over 3 is for an angle. That's I may not be perfect, but that's about 60 degrees. Okay? And this is where 2 is. Again, that's my spot. Now, it doesn't say, well, actually it does. It says plot the point given in polar coordinates. Okay, good. Done. I've plotted it. But now they want me to give it with a negative r. And here they want to give it with a negative angle. And here they want you to use a positive r, but a really big angle. Hint, on this kind, why don't you just write this? Add 2 pi to the normal angle that you would have said before. So in other words, let's do that part right now. Here's pi over 3. That's right there, right? How else could you get there? All the way around the circle again, which adds another 2 pi, would have gotten you there too. So it's 2 comma 2 pi plus pi over 3, or pi over 3 plus 2 pi. Now, do we have to actually add them? Yes, you do. So you need a common denominator. So then I make the common denominator thirds. So yeah, that's 6 pi over 3 plus 1 pi over 3 makes your final answer then 2 comma what? 7 pi over 3. That's making it with a big angle. Here's making it with an r that's positive and an angle that's negative. To get to this same spot right here, I could have used a negative angle to get there. And if this is pi over 3, then I could think of this as negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3. Negative 5 pi over 3, and the r for it, the radius for it, is 2. So this would be 2 comma negative 5 pi over 3. I'm doing this whole first one for you. Just stay with me for one more minute. We're almost out of here. This one is where they want the r to be negative. That's one of the trickier kinds. I've tried to teach you that you want to find the spot that's directly across from the spot you want. So like right here. So I need to say r is negative. That's really simple. It's negative 2 comma. But what angle would it be? You take where it would be if it was over here, which is this angle, pi over 3, plus another 180 degrees, or in this case, pi. So pi over 3 plus pi. Would you agree that the same as 3 pi over 3? So final answer on this one would be negative 2 comma 4 pi over 3. That's this same point, except written with a negative r. This is the same point written with a negative angle. And this is the same point written with a really big angle, because they just took the angle and added 2 pi to it. If you need to, you can always go back and watch this video again later to get some help. I'm going to let you guys go, and you be quiet as you go, and I'm going to explain a little bit more for the kids at home for the other part of your assignment. And you can always watch this later if you want to. Okay, a little bit more help for you. Again, I apologize for this video being so short, but I have to run now to lunch or I won't get any lunch. This is where they're giving you a negative point in polar. I want to show you one of those. So here's the way I would do this. First of all, I got to figure out where 5 pi over 4 is. I always do the angle first. Here's where 4 pi over 4 is. So 5 pi over 4 is just a little further. So it's all the way around to here. And that makes this angle right here pi over 4. But the whole thing is 5 pi over 4. Now, if it had been a normal 4, you'd go out 4 and put a dot right there. But this is not a normal one. It's a negative 4. So that just means opposite of 4, opposite direction from this. So then I go opposite direction is over this way. And I hope you can see with vertical angles that this angle right here also is pi over 4. And the dot that would land right here would be at the same exact spot as this, except written with normal polar coordinates. It would be at pi over 4 and same radius of 4. Hopefully you can see that that and that will get you to the same exact spot, which is right here. You might be saying, why did you put a spot here? It was to help me find this. If this had been a positive right here, then this spot would have been here. But I then teleported it over here because it was in the opposite direction. So this spot is right here, and this was just a helper point. Okay, now the one I just figured out here has an R that's positive. I'm going to pause for a second. It has an R that's positive and an angle that's a small positive angle. All right? They didn't ask for that in any of these three, but it's still going to be helpful to know the original polar coordinates for this spot. So now I got to find what they're asking for here. They're asking for a negative R. Well, hey, I already have a negative R. Awesome. So negative 4, comma, and they want an angle that's between 0 and 2 pi. Well, I would argue that this already is an angle that's between 0 and 2 pi. Okay? Now, if you wanted another one, you couldn't get it because we already have the one place that has the positive angle and the negative R value. So A is this point right here. Okay? Now for B, they want an R value that's positive. All right, that's kind of like this one. But they want an angle that's less than 0, as in a negative angle. All right, so to get this point right here, that's the point in question. This original point from right here. If we want to write it with a negative angle, how do I get here using a negative angle? I go all the way around here. And how far around am I going to need to go? Well, almost, since we're using pi over 4s, almost 8 pi over 4, but not quite. So that makes it negative, not 8 pi over 4, but negative 7 pi over 4. And the R value is still 4. So there's one that has a positive R value and an angle that's negative. Okay? And lastly, we needed an R that's positive, but we wanted to use a really big angle, an angle that's bigger than 2 pi. What you do for that is you take this normal polar coordinates for it, and you say, I've already got a positive R value. How can I make this bigger but still hit the same spot and still stay positive? You just add 2 pi to it because that's the period within a circle. It'll wrap you all the way around. So you're heading, instead of this blue one here, you're heading, already went pi over 4. Now we got to go 2 more pi all the way around the circle again to there. So that's 2 pi plus pi over 4. Think of that 2 pi as 8 pi over 4. That's the same as 2 pi, right? And then we'll add that pi over 4 to it, and then we'll have 9 pi over 4. So it's 4 comma 9 pi over 4. Okay, there's an example of how you do that kind. And moving on, I said you could skip problem 16 because I felt like there was just a few too many problems here. And then in 37 through 45 here, they're giving you rectangular coordinates. So you have to figure out how to change those into polar. All right, so where is 0, 5? Picture's worth 1,000 words. I recommend a picture whenever you're getting stuck. 0, 5 is that dot right there. I bet you can tell me what that is in polar. It's 5, comma, and I'll let you figure out what angle that is. Shouldn't be too tough, just say it in radians. Okay, here's a tougher one though. 3 comma root 3 over 3 up root 3. How high is that? I don't really know. I know it's 1 point something, so it's not real high. This was 3. This was square root of 3. Do you get, I just got there the normal way with rectangular coordinates, the coordinates you're used to since like the beginning of time. And now we're supposed to do polar for this. So this angle right here is the angle we need to do the r comma theta. The radius right here, we'll need that to do our r comma theta. So our polar coordinates always have the radius, distance, and then an angle. So r in this case is this radius, which is the square root of this squared, which is 3, plus this squared, which is 9. 9 plus 3 makes 12, square root of 12. Yes, that can simplify to root 4 and root 3, which would be 2 root 3. Okay, so that side right there is 2 root 3. That means our r is 2 root 3. And our theta, our angle, the angle in question here is this angle right here. Now, I don't have this one memorized. Okay, so would you agree that you can do inverses then if you need to know an angle? The inverse in question would be inverse tan, because we already have the opposite and the adjacent sides from this angle. So inverse tan of root 3 over 3. That's the angle that we'll need to put right there. Now, if you have a human calculator in your head and you can do that, awesome. Otherwise, you can leave inverse tan of root 3 over 3. Now, this happens, a lot of kids may not know this, but this happens to be 1 over root 3, okay? And if you look at the triangle for that, this is the same exact thing as this, and therefore tangent, where this is 1 and this is root 3, I bet you know that triangle, don't you? And therefore you can figure out the inverse tan of root 3 over 3, because it's really just the tangent of some angle gives us 1 over root 3, and that means it's this angle, and that means it's a 30-degree angle, also known as pi over 6. I know that got pretty intense, so I wanted to give you a little bit more help before I stop the video for today. So, all right, there's some help for you for polar. Not my ideal lesson because it already died when I tried to record it the first time, so at least this is something for you. Have a great day.